Hey guys, guess what? Good news. This is your last lecture of your Algebra 2 career in my classroom. So, here we go. Notes for the week of May 18th, 2020. The topic that we're talking about here is radicals with higher indices. That's the plural for index, by the way. And this is 6.7 in varsity. Let's see. Anything else you need to know? I think that's it for the time being. Okay, so here's just a little bit of a reminder. In the radical, the index is right here. It's a little number. So this would be the index. It's a small number, kind of like a superscript, like x squared. It's a small number. And if you don't see a number, if the index is invisible, then it is a 2, hence a square root. Okay, if it's any number other than 2, you're going to physically see a number in there. Okay, so something like a cube, a 3 in there, so that'd be the third root of something, the fifth root of something, the fourth root of something, right? That little number will be there in the index. Okay, so here's a reminder for you. When you simplify a root, a radical, actually, we'll change that number. You group, and you already know this because you've been doing square roots for a little while now. You group the number together number of factors together to equal the index. To get them out from under the radical. You already know that, right? You've been grouping things together in groups of 2. Well, that's why you've been grouping them in groups of 2. Okay, and then there's another note here. I'll change my color so it's obvious. Also, your answer must have the same index as the problem. Okay, so if you get a problem with an index of 3, your answer has to have an index of 3. All right, so let's do a couple examples and then we'll be done. This isn't terribly difficult. The biggest problem is people forget to put this, they forget this. They don't put the index in their answer. So we'll make sure that you revisit that. All right, here's the example number 1. We're going to do let's do this first. Just as a reminder, so this is to remind you, if we see this, that means this index, excuse me, this has an index of 2, even though you don't see it. And so when you guys break this up, we'll go rad 6, rad 8, rad 3, rad 2, rad 4, rad 2, rad 2, rad 2. Okay, and so you did groups of, that gave you a 2, this gave you a 2. We multiply these together, right? So 2 times 2 is 4, radical 3. You've been doing that for a while now. Now let's see how that differs if you have an index in there. So the cube root of 48. Okay, I'm going to break this down the same way. Oh, side note. When you have an index, take your factoring all the way to primes. Right? There is no such thing anymore as the square root of 4 because you're taking a cube root. So you can't just simplify a 4 to a 2 or a 36 to a 6. You can't do that. So this is super important. Make sure that you take these things all the way down to prime factors. Okay, so 48, I'm going to break down exactly the way I did up above. I'm going to go rad 6, rad 8. Now these are really cube roots, but I'm going to leave the cubes out of the work and just put that into the answer. And then we have rad 3, rad 2, rad 4, rad 2, rad 2, rad 2. Again, getting rid of your composites. Now, because I'll use a highlighter here. Because the index is 3, you need to group 3 of the same number together. So 1, 2, 3 of them will give me a 2 as a result outside of the radical. Okay, anything left over will get multiplied just like it did before. So we're now going to go 2 on the outside, cube root. Don't forget the index in the problem has to match the index in your answer, and you're going to have a 6 under here. So 2 cube root of 6. Let's jump over to varsity and make sure you guys know how to put that into varsity. Okay, so I'm going to go to varsity. In here, when you click inside this box, you're going to get the builder here, and I would highly recommend you use the builder. Click on that. And then notice here, this is your square root where you don't have an index in it. You want the one next to it where you have an index of an n, which you can change. When you click on this, it will automatically make it a 3. But you can click up here, backspace, and make it a 4 or make it a 5 if you need to. And then you just put your answer underneath the radical, hit save, and it will put in there whatever you need. So let's say we had an 8 in here. I don't have a keyboard. It's not important. As long as you know where to find the cube root. That's the important part. All right, so let's go back to the notes. Couple more examples, and then we will be done. All right, your next example. Let's do, this is example 3. Let's do the cube root of 160. So I am going to break this down into 16 and 10. 16 is 4 and 4. 10 is 2 and 5. Now make sure you don't lose track of these as you go, right? Those two are both prime, the 2 and the 5. Each of these need a couple of 2s, though. Okay, so now we have, let's see, we need, our index is 3. So I have 1, 2, 3 of these that are going to give me a 2. And then I have a 2, and a 5 that don't have a triple, I guess. I can't say pair up because they're not pairing. You need 3 of them. So this 2 is going to come out. And then the cube root, 2 times 2 is 4, times 5 is 20. So we're going to have the cube root of 20 inside that box. Okay? What happens if you have a higher degree? Same basic idea, except you're going to circle different values. So let's do example 4. The 5th root of 320. Okay, I'm going to go 32 and 10. 10 goes to 5 and 2. 32 goes to 8 and 4. 4 goes to 2 and 2. Let's get rid of these as we go. The 8 goes to 4 and 2. The 4 goes to 2 and 2. All right, so my index is a 5. That means I need 5 2s. 1, 2, 3, 4, 5 to get a single 2 out from under that radical. Okay? And then anything that's left over gets multiplied and put back underneath. And you have to have your index. So we have a 2 out front, and then we have an index of 5. So we have the fifth root of 10. And that's what that would look like and simplify to. All right, let's do one with variables, and then we're done. So the last one, example, what are we on? 5? Yes. Example 5. Looks like the cube root of 1296, a to the 7th, b to the 6th, all underneath the root. Now, what I would do first is separate the radicals. Separate radicals. So I would have the cube root of 1296. I would have the cube root of a to the 7th and the cube root of b to the 6th. Now, if you recall, all we did last time with variables was write them out and circle pairs. Well, now we're going to circle 3. So this is going to be similar, a little different. 1296, I did this earlier, and this is rad 16 and rad 81. And a reminder, this is the root of 16 here is not 4, because this is really a cube root of 16 and a cube root of 81, right? So don't simplify these even if you see perfect squares, because they're not really. So the 16 is going to go to a 4 and a 4. Each 4 will go to a pair of 2s. The 81 will go to a 9 and a 9. Each 9 will go to a pair of 3s. Okay, so now I need 3 of them. So 1, 2, 3 2s. And then 1, 2, 3 3s. And then these will get multiplied and left underneath. So just for the number, I have 2 times 3 is 6. And the cube root of 2 times 3 is 6. Okay, so this is only a part of my answer. So we're going to combine all these parts at the end. Now, the cube root of a to the 7th. Cube root, 1, 2, 3, 4, 5, 6, 7. Right? You're going to group them in groups of 3. So this is going to be a squared cube root of a. Right? The a squared is coming from there, 2 groups of 3 a's. And then the cube root of 1, 2, 3, 4, 5, 6. Group these together in groups of 3, so that'll be b to the 2nd. There's nothing left over, so there will not be anything left under the root. Now we're going to take everything out in the front. So the 6, a squared, b squared, those will all be part of our answer out in the front of the radical. Then my cube root, and then anything underneath. So I have a 6 and an a underneath, and that's going to be it. Okay? So you're going to see some like that. So same as before, you guys are going to do, did I say this was 6.7? Yep. 6.7 in varsity. Okay. And notes for the week. If I have your notes by Tuesday, you'll get extra credit. Everything's due by Friday, May 22nd. And just so you know, kind of what the plan is the following week, which would have been exams, so the week of the 25th will be makeup work if you have any or need to go back and do some things. And there will be no exam. Okay, so wherever, this is really your last 2 assignments right up here. Whatever your grade is at the end of those is what your grade's going to be, unless you decide to go and do makeup work, which I will take. There will be a late penalty if you do it, but I'll be happy to open things up for you and stuff. Okay? All right, kids. It's been fun. I'll see most of you in Algebra 3 next year. Toodaloo.